Hey everyone, thanks for watching How To Pixel, and this is part 2 of the two-part series about the new F16v5 Pixel controller. If you missed part 1, I recommend you check it out here because it has a lot of useful information that you'll need for this video. But if you've already seen part 1 and you're ready to see part 2, then stay tuned because this part has all the information on how to set up and use the Pixel controller. So, let's get started. So just for a quick recap, if you don't remember part 1 or you haven't seen part 1 yet, but you want to know just how to use the web interface, in part 1 I talked about all the components on the controller, some of the new features on the controller, like the E-fuses or the built-in differential receiver outputs. I talked about what the controller does, how many pixels it can support, and what all of the buttons and components on the board do. I also briefly talked about differential receivers and how they work with the F16v5 too. So that was part 1. But now in part 2, I'm going to be talking about how you use the web interface for the controller, which is where you change all of the settings on the controller to tell it how many pixels you have connected, what type they are, the different modes the controller can be in, whether it's running alone by itself or if it has a show player sending it data, or if it's wirelessly talking to a show player, all of the different modes, and all of the main setup for the F16v5 will be in this video. Like always, I'll have the timestamps in the scrub bar and in the description below, so you can skip right to whatever you want to see. And if you want to get right into the tutorial, then skip to this time right here. But I have a few other things I want to talk about first if you want to stay for that. First, I quickly want to talk about some terminology I messed up in the last video, and I do mess it up in this video too. But there were a couple of people that corrected me on this in the comments, and I want to make sure everyone knows so they don't get confused. In the last video, I was talking about these 5 red Ethernet ports, as I called them. And these are not network ports. You don't connect these to the internet or anything. This is just to connect differential receivers or DMX, LOR, Renard items to the board. I kept calling them Ethernet ports because they actually look like an Ethernet port, but that's not the correct terminology you're supposed to use with them if they don't work with network data or connect to your router or anything. These are technically RJ45 connectors. So these 2 ports are actually Ethernet ports, and you can connect them to your computer, to your router, to networks, whatever you want. They're actual Ethernet ports. The rest of them are referred to as RJ45 connectors, and they are not actually Ethernet ports since they do not connect to the network or to your computer or router, and if you do connect it to there, it could damage the controller. So just know that those are called RJ45 connectors, only the black ones are Ethernet ports. And I do mess it up a couple of times in this video, but I'm going to make sure that in future videos I refer to those as RJ45 connectors and the black ones as Ethernet ports. So that's what I quickly wanted to address before I started the video, but now that that's done and over with, we can get started with the tutorial. And the first part is going to be how you connect to the F16v5's web interface. So for those of you that are new to these type of controllers, all Falcon controllers have a web interface, and this is where you change all of the settings and adjust everything for the controller. This web interface is pretty easy to get to, and you can connect to it from a browser, on your phone, on a tablet, but it's usually easier to try and connect to it from a computer because your screen's bigger. It allows all the settings to show up, and it makes it a lot easier instead of trying to use a big finger to try and hit all the settings on the phone. You don't need any fancy type of computer, and you don't even need internet access to connect to the controller. As long as your computer has a browser, it will work. There are 2 ways to connect to the web interface. The first one is the normal one, and it's connecting the F16v5 to your network and then talking to the controller through your network with your computer or phone or tablet. And the other way is if you don't have a network, to use the hotspot that the F16v5 has built into it. If the F16v5 does not detect a Wi-Fi or Ethernet connection, it will automatically turn on its Wi-Fi chip to activate its hotspot. If you go to your Wi-Fi settings on your computer, you should be able to see it, but it has a very, very low range, so you're gonna have to be right next to the controller to be able to connect to it. It doesn't have a password, so all you do is connect to that Wi-Fi network, and then on the screen of the F16v5, it will show its IP address. So then if you open any browser, you won't have any internet connection since the F16v5 can't connect to the internet, but you will be able to connect to the F16v5 by putting in that IP address into the browser. For example, if the screen shows something like this, that is the IP address you need to use to connect to the controller. So open your browser and type that number in exactly. Make sure to include all of the periods, don't put in any extra characters or spaces, just put in that number. And then if you hit enter, you should be able to connect to the F16v5. and now you're inside the web interface and can begin making changes to the controller. The other way to do it, which is the more common way, is to connect it to your network. It's easiest if you can hardwire it with an Ethernet cable into your router, but for a lot of people that's not an option, and you can't tell the controller what Wi-Fi network to connect to and the password of it except through the web interface. So if you can't hardwire it, you'll have to use the hotspot first, connect to it, go to the network settings, and then put in the Wi-Fi information to connect it to your network with Wi-Fi. But if you can use an Ethernet cable, it's super easy, and all you have to do is hook an Ethernet cable between the router and one of the black Ethernet ports, not the red RJ45 connectors. Plug it into one of the black Ethernet ports, and then your controller will automatically connect. And then on the screen, it will show its IP address, and you can go and type that into a computer and connect to it. Make sure though that whatever device you're using to connect to the controller, whether it's a phone, a tablet, or a computer, that it's on the same network as the controller. I know this all could be a little bit confusing, and I hope to make a networking video sometime in the future that involves also a Raspberry Pi and the controller, connecting them together. But for now, that's the easiest way to connect to the controller. And once you get to the web interface, it'll look something like this. But now we can get into how to use the web interface, and we'll be starting with the first page, the status page, which is the main page of the controller. So let's get into that. The status tab is the main tab of the F16v5 and shows you useful information about the controller. It also has a couple of settings such as the controller mode and the button to turn on and off all the eFuses. The board configuration setting allows you to change the configuration of the ports on the controller. For me, it's set for 16 local ports plus 4 smart receiver chains. This is because I'm using the 16 ports on the controller and I have smart receivers chained off the Ethernet ports on the top of the board. The controller mode setting is basically what it sounds like. It allows you to change what mode the controller is in, such as whether it's receiving data from a show player and sending it to the lights or running in standalone mode. E1.31/ArtNet, ZCPP, and DDP are all modes where a show player sends data to the controller to be converted to pixel data for the lights. Each mode is a separate type of data different show players may send out, but the most common show players such as Falcon Player or Xschedule use E1.31/ArtNet data. Master and remote mode is where there's a main computer, the master, that tells all the remotes when to stop and start the show. The F16v5 can function as both a master and a remote, but you generally get more features when you have a computer, such as a Raspberry Pi running master mode. When using master and remote mode, no pixel data is sent between the controllers and or computers, but instead, just a small amount of data that keeps all the controllers in sync. Each device running remote mode would get a copy of the sequence files, then the master would wirelessly send a message to the remotes to start and stop the sequences. It will also keep them in sync. This is good to use when you can't run an Ethernet cable to your controller from your computer. If the controller is running in remote or master mode, you will need the sequences on a micro SD card, and you'll have to insert that into the SD card slot. The final mode, player, is where the controller runs all by itself without a show player. It keeps the sequences on board in an SD card, and you schedule when to stop and start the sequences. This works better if you want a smaller and cheaper setup, but you don't get as many features and options as you would with a show player. If you make any changes to these two settings, make sure you press set afterwards. The Save Setting button allows you to export all the settings on the controller into a file on your computer. The Load Setting button allows you to restore any of those files you have saved back onto the controller. This works great as a backup in case you lose your settings on the controller. Below that is all the controller information stats. You can see the controller's name, uptime, temperature, and more. Temp 1 is the temperature on the left side of the board, and Temp 2 is the temperature on the right side of the board. Voltage 1 is the voltage coming into the V1 terminal, and Voltage 2 is the voltage coming into the V2 terminal. You can see I have a 12-volt power supply connected to V2. On V1, I currently have no power supply, but sometimes the controller still gets a small voltage reading. The fan RPM is the speed a fan would be running at if one was connected to the board. You'll see below all of this information, there's also two graphs that show the voltage and temperature over time. On the first graph, I can see the V1 and V2 voltage, and on the second graph, I can see temp 1 and 2 and the processor temperature. Below the graphs are the fuse control settings. I can see the status of any eFuses as well as reset them or turn them on and off. This section is all the fuses for the ports on the left side of the controller. The next section is all the fuses for the ports on the right side of the board. All of the other sections are for the fuses on the differential receivers. You'll notice a lot of them are black and say unknown, and that's because these are older receivers that don't have eFuses on them. A blue color means the fuse is good. A black color means the status is unknown, probably because it's on an older receiver. A gray color means the fuse has manually been turned off, and a red color means the fuse is blown. If you have a blown fuse, once you've fixed whatever caused the fuse to blow, you can click reset to reset all of the fuses. If you want to turn off all of the fuses, you can click the turn off button. If you want to turn off just a single fuse, you can double click the circle and it will then turn gray to show that you have manually shut it off. You can double click it again to turn it back on. Additionally, you can right click any fuse to open the Visualize tab for that port, but we'll get to that later in the video. If you have any F8 power distribution boards connected to a receiver or your controller, you can also turn those off from here. Any receivers with automotive fuses will not have the fuse control options. The final section on the status page is the E131 packets received section. This will only show up if the controller is running in E131/ArtNet mode. If it's running in a different mode, there'll be a different page down here. But for E131 mode, this shows you how many universes of data the controller has received and where the data is coming from. You can see my controller is set up for 32 universes and the data is coming from this IP address, which is my Raspberry Pi. To the right of the universes, you'll see the packet count, and this shows how many packets of data have been received for each universe. You can reset this section or manually update it if you have live updates disabled. The next tab is the testing tab. Here you can activate test patterns to make sure your lights are working. If you haven't set up the output settings yet, your lights may not work or light up properly, so make sure you have that done first. You can click the drop-down box to select different test patterns, then click Enable to begin the test. You can also change the speed as well as enable and disable certain ports from running the test. You can uncheck the enable box to turn off the test pattern or press the test button on the controller to turn it off. The third tab is the input tab. Here you can set up input triggers to activate different events if a complete circuit is made on either of the input terminals. There's multiple different events you can set up as well as test the events to make sure they work. Make sure to click save if you've changed any of the settings. You can also hit clear to get rid of all the input triggers. Fourth is the network tab. This is where you set up the Ethernet and Wi-Fi interface to connect to your network and or show player. The top box is the Ethernet configuration and the bottom is the Wi-Fi configuration. This page can be a little bit complicated to set up, so I'll talk more specifically about it in a future video. However, if you're familiar with networks, this page shouldn't be too complicated for you. You can enable or disable DHCP for each interface, as well as connect to a Wi-Fi network by putting in the name or SSID of the network. You also have to put in the password for your Wi-Fi network so it can connect. If DHCP is checked, the controller will allow your router to automatically give it an IP address so you don't have to set it up manually. However, your router may periodically change it, so most people set up a static IP address manually. Like I said, I'll have a video for this in the future since it's a little complicated and I feel like it should have its own topic for a separate video. Next is the E1.31 tab. This is basically the input data or incoming data tab that only has to be set up if you're using E1.31/ArtNet data. Here you tell the controller how many universes of data it will be receiving from the show player and what type it is. You're basically telling the controller what to expect from your Raspberry Pi or computer wherever your data is coming from. To add a new input, click the Add button. It will then open this box of 4 different settings. The first one is the start universe, or the number of the first universe of data it will be receiving. If this is your only controller in your setup, then this would be left at 1. The next setting is the universe size, or how many channels the universe will have inside. It can be set for any number between 1 and 512, but the 2 most common numbers used are 510 or 512. Some older controllers only accept up to 510 channels per universe, but the newer ones can accept up to 512. It doesn't really make a huge difference, just set it to 512 if your show player can handle it. The third setting is the universe count, or how many universes of data the controller will receive. And then the final setting is the type of data. The 2 options are E131 and ArtNet. Most people use E131, but common show players will work with both. If a lot of this doesn't make any sense or you're unfamiliar with universes and channels, I'd recommend checking out this tutorial that explains how they all work and how it's set up. The video will definitely help you understand a lot more settings in the controller. Once you finish setting up this page, make sure to press save. You can also copy selected universes, delete them, or delete all universes you have set up. The 6th tab is the recorder tab. This page allows the controller to record data coming in from your show player and save it to an FSEQ file. You'll need an SD card inserted into the controller for this to work. This feature can be helpful if you need a sequence on an FSEQ file but don't have a way to convert the original file. This page is more on the advanced side, and for a regular light show setup you probably won't use it. The next tab is the output settings tab, and this has 2 different sub-tabs under it: serial outputs and pixel outputs. First, I'm going to go over the serial output tab. This tab is where you set up the DMX Ethernet port to output data if you'll be using LOR, Renard, or DMX items on your controller. The first setting is the protocol, for what type of data to output. If you're going to be using LOR, then you'll just have to move the jumpers on the board to switch it to LOR data. If you are using DMX or Renard, you can select that here. Next is the Start Universe setting. Here you put in the number of the universe that the DMX, LOR, or Renard item will be using. The other setting is the Start Channel. This is the first channel your item will be using on the DMX Ethernet port. The addressing mode setting allows you to change how you'd like to address your outputs. Universe/start channel is where you put in the first universe and channel the data will be using, like I showed. The absolute addressing setting uses just channels to address your outputs, but this can often make the number bigger. Universes can be described as like a group for your channels. So you could say something like channel 30 inside of group 4, where the group is representing the universe. But with just channels in absolute addressing mode, you have to have one giant channel number since you won't be using those quote-unquote groups. So instead of channel 30 universe 4, it would look something more like channel 1566. If this is still confusing for you, I explained this way more in depth in my universe and channels video I showed a second ago. After making any changes to the page, make sure you push the save button to save your settings. You can also push clear to get rid of all of the settings. The other page under the Output Settings tab is the Pixel Output page, and this is where you set up all the pixels the controller will run. On this tab, you tell the controller how many pixels will be on each port, what the start universe and channel should be for each port, how many different receivers the controller will run, and more. This page may look very confusing to set up, and I'll be honest, it kind of is. But once you get over the learning curve, everything will start to make a little bit more sense. And nowadays, if you use Xlights as your programming software for the lights, it has a feature that automatically uploads all of the output settings to the controller so you don't have to do any of it. So don't worry if this page is confusing, it's super easy to set up with Xlights. Now I'm still going to explain what the settings here do just because it's good to understand how to use this page if you need to change something manually or you want to set it up yourself. Near the top, you have the same addressing mode setting like you have in the Serial Outputs tab. You can select either Universe/Channel or Absolute Addressing for all the ports. I'm going to leave it on Universe/Start Channel. Each one of these individual rows is the settings for a single pixel port on your controller or smart receiver. Each port has 14 different settings for all of them, and all the ports are numbered. There's also two different colors of ports. There's the red ports and then there's the green ports. Any ports that are in red are the ports that are physically on the controller. Any green ports are the ports that are on a smart receiver that would be connected to the controller. The first setting you'll see is only available for port 1 and it's the pixel type setting. This setting allows you to change what type of pixels you'll have connected to the F16v5. There are tons of different pixel types and you can click the question mark to see all of the types supported by the F16v5. The most common type of pixels is WS2811 pixels and that's what I'll leave it on. Now the reason this option is only available on port 1 is because all of the pixels connected to the controller have to be the same type of pixels. On older models of the F16, you used to be able to change what type of pixels you had for each individual port, but now they all must be the same. However, your differential receivers can be set to use a different pixel type than the rest of the ports on the board. If you scroll down, you'll see the type setting available in the green ports as well. And this is where you select what type of pixels the receivers will be running. You'll notice there isn't as many pixel types supported for the differential receivers, so if you have a pixel type that isn't in this list, you'll have to connect those to the main ports if the board supports it. So the controller can technically control two different types of pixels. All of the ports on the board must use the same type of pixels, and all the receivers must use the same type of pixels, but the onboard ports and receiver ports can be different. The next setting is the description. If you'd like, here you can give the port a name so you know what prop or pixels that port will be controlling. After that is the Start Universe. This is the first universe or group of data, as I call it, going to that port. Then there's the Start Channel. This is the first channel of data within the universe or group that the port will be receiving. If you don't know what these are supposed to be set to, you can look inside the Layout tab in Xlights and click on each prop to see what universe and channel it starts on. After that, you have the pixel count. This is set to however many pixels the F16v5 will be controlling on that port. If I have 150 pixels on that port, but I only have it set up in Xlights for 100, you'd still set this setting to 100. The group count setting allows you to group multiple pixels together to act as one pixel. For example, if I have a strand of 100 pixels and I want 10 groups of 10 pixels each, then I would set this to 10. Now you only have to program 10 pixels in X lights, and each group will all light up the same color. If the group count does not evenly fit into the pixel count, then it will turn red to show that there's an error. If you don't want any pixel groups, then leave this at 1. The N universe and N channel numbers just signify what channel in universe the strand of pixels ends on for that port. These do not need to be adjusted, it's just simply giving you information. The direction setting allows you to change what direction the strand of pixels go. For example, if I have a strand of 100 pixels and I want the data to flow normally with this being pixel number 1 and this being pixel 100, I would leave it at forward. But if I want it to be reversed with this being pixel 100 and this being pixel 1, I could select the reverse option. Now the data for the first pixel, instead of going to the beginning of the strand, would go all the way to the end of the strand. The order setting allows you to change what order the colors are addressed inside the pixels. In most pixels, the red LED is first, then green, then blue. If you have pixels with a white LED inside as well, then that usually goes after the blue one. If you have the wrong color order set for your pixels, they won't light up correctly and the colors will be mixed up. For example, if I try to turn on a green pattern, all the lights might turn on blue, and that would be a sign that the color order is set up wrong. So make sure you check what color order pixels you have, then set that here. Most of you will have RGB pixels, and the RGB stands for red, green, blue, because it's addressed in the order of red first, then green, then blue. So if you have RGB pixels, select the setting that says RGB with white in the brackets at the end. Even if your pixels don't have a white LED inside, leave the W at the end because it will still work fine. The start and end null settings allow you to skip pixels at the beginning and end of the strand. For example, if I have this strand of pixels and I want the data to start here with this being pixel number 1, but these 2 pixels are in the way, I could just set the start nulls to 2, and now the data will skip the first 2 pixels. You could do the same as well at the end of the strand with end nulls. Adding null pixels will not increase the number of pixels you can have on one port, since there's still data going to those pixels. So even these null pixels will still count to the total number of pixels I have on that port. The zig count allows you to zigzag the pixel data for the lights. For example, if you have a matrix setup with the data zigzagging back and forth, but it's set up in X lights to be wired from one side, you can enter in the zig count how many times to zigzag the data. So that way, after a certain number of pixels, the data will be reversed to make the designs look right on the matrix. The brightness setting allows you to adjust how bright the pixels are on that port. I usually use 30% brightness because pixels are very, very bright even at 30%. The higher the brightness level is, the more power your pixels will take. The gamma setting allows you to correct the gamma of the pixels and make the colors appear better. There are 5 preset options or none if you don't want any gamma correction. The final setting for each port is the blank checkbox. By clicking the blank box, it enables blanking and will turn off the pixels if no data is being sent to them. You can adjust how long the controller waits to blank the pixels in the settings tab. Now this concludes all the settings for each port, however there are still a few buttons on this page. As you'll see, each port has a black plus sign next to it. If you click it, it adds another row of settings just for that port. This is called a virtual strand, and it's a little advanced, but it basically allows you to have 2 sections of your pixel strand be set up differently on the port. For example, if I have 100 pixels total on this port, but I want the first 50 to be brighter than the other 50, I can add a virtual strand. Then after that, I could set the top section to only control 50 pixels at 70% brightness. Then on the bottom section, I can set up the other 50 pixels and have those set for 30% brightness. You still need to make sure that you have your start universe and start channel set up correctly for each section. You can add even more sections by pushing the plus button again. If you push the minus button, it will get rid of the virtual strands. There's also a blue button on certain ports. By clicking this one, it adds a differential receiver to the controller to be set up. You can also click the minus blue button to get rid of the differential receivers. I'll explain more about how you set up the differential receivers in a future video. The final buttons at the top allow you to save the settings, clone an output to another, clear any invalid settings, clear selected ports, or clear all the ports. And that is all the settings for the Pixel Output tab. The next tab is the Settings tab. Here you can find most of the general settings for the controller, such as the time setup, debug settings, and some other things. The protocol priority setting will make the controller only use the input with the highest priority if enabled. This is useful if you have multiple devices sending the controller data. If this is selected, the controller will only listen to the device that's set up with the highest priority. Use protocol synchronization will wait to send any data to the lights until it receives a sync packet from the show player. The pixel blanking timeout is how long the controller waits to send a blank signal to the pixels after no data is going to them. This only works if you have the suppress output box checked, and it will only work for ports that have the blank setting enabled. You can adjust the time for how long it waits until it sends a blank signal. The fuse hold time works hand in hand with the pixel blanking setting, and it will shut off all of the E fuses after no data is sent to the controller. Once the pixel blanking setting goes into effect, the controller will wait however many seconds the fuse hold time is set to, then it will turn off all of the fuses. This is useful if you don't want power going to the pixels when no data is being sent to them. This only works for the ports onboard and receivers with E fuses. If a strand has power injection going to it, then turning the fuses off won't do anything since it'll still have power from the power injection. However, if your power injection is coming from an F8 power distribution board, those will also turn off after the fuse hold time is up, so there's no power going to the pixels at all. Once the controller receives data again, it will turn back on all the fuses. The time settings allow you to adjust the controller time and pick an NTP server to get the time from. If the controller does not have internet access, it will not be able to get the time. You can also manually set the time and date, but the controller will forget it once it powers down unless a battery is inserted under the OLED screen. Appearance settings allow you to adjust the appearance of the web interface. You can change the color of the bar at the top of the UI, which is helpful if you have multiple controllers. When you have all of your controller tabs open, it makes it a lot easier to tell which controller is which by the color of the bar. Dark mode will invert any black and white colors on the web interface to make it less bright. Invert show logo will invert the colors of your image at the upper right hand side of the UI if you have one. If you take a picture off your computer and name it showlogo.jpg, put it in an SD card, and put it in the controller, that picture will then show up here. The invert show logo setting will allow you to invert the colors of that picture. Low voltage detection will display a warning on the OLED screen if a voltage of 4.7 volts or lower is powering the controller. Voltage this low will cause multiple features on the controller to stop working, including the web interface, so a warning will be displayed on the OLED screen. Internet access allows the controller to access the internet if checked. This box must be checked for the controller to be able to get the time from the NTP server. The debug settings allow you to see logs about what is happening with the controller, but are for more advanced users or developers, so they should be left at the default setting. Finally, the firmware settings allow you to update the firmware on the F16v5 and V5 or newer smart receivers. By clicking the Update Firmware button, you will be able to upload a file to update the firmware on the controller. The same goes for the Update Receiver firmware as well. If you have any V5 or newer smart receivers connected to the F16v5, you can send them new firmware to update the boards over the Ethernet ports. Back at the top, the Save button will save all of your settings after making changes. The Reboot button will reboot the controller, and the Restart Wi-Fi button functions like the button below the Wi-Fi chip. It will reset the Wi-Fi chip if it is not working properly. Finally, the Reset Controller button will restore the factory defaults to the controller if pressed. The Visualize tab will open a new window and allow you to visualize how many pixels are on each port. This works somewhat like the X-Lights visualizer and allows you to see information about each port if you hover over it. The coolest part about this page is if you click the small box below each port for the smart receivers, you can see even more information such as the temperature of the receiver, the voltage, the live amperage being measured on that port, and there's even a count button. When you push the count button, the controller will send data out through all the ports on the board and the receivers to count and tell you how many pixels are on each port. The way it works is it will light up one single pixel on each port, then turn it back off. Then it will move one pixel down the strand and do it again, continuing down the whole line of pixels, lighting up one at a time in order. Since the F16v5 can read the amperage of each port, it detects a spike in amperage every time the light turns on. If it sees that spike of amperage, it knows that it turned on a pixel, but if it doesn't, then it knows that that's the end of the strand or there's no pixels on that port at all. Once it's done counting, it'll add all the amperage spikes and it will know that that's how many pixels are on that port. If a strand of lights on a port has power injection, this will not accurately count your pixels since the power injection will be taking some of the amperage. However, if you have an F8 power distribution board with E fuses, when you click the count button, it will turn it off to disable power injection, then it will be able to accurately count the pixels. The controller is able to do this all in seconds, however, it only works for onboard ports and receivers with E-fuses. If you try to visualize a port with a V4 or older receiver, most of the stats will not show up since they do not have two-way talk. So all of these fancy new features only work for the ports that are on the board or V5 or newer receivers. If you want to visualize an onboard port, instead of clicking the small box, click the actual port to open those stats. The refresh button will update the page and refresh all of the information being shown. The monitor tab opens a new window and allows you to connect multiple controllers to this page. This allows you to monitor all of your controller's information from one window. You can add or remove the IP addresses of your controllers by clicking these buttons. And finally, the good old help button. If you're having any trouble figuring out how anything on the controller works, you can find tons of useful information by clicking this button. Oh. There is absolutely no information out for the F16v5 yet. Well, that'll conclude this tutorial. Congratulations, you made it through both parts of the F16v5 controller tutorial. Now you should be able to set up and use the F16v5 and know what it's doing and how to set it up. I know there's probably a ton of information between these two parts, so if you're confused about anything or have a question, please feel free to leave it down below in the comment section and I'll try to respond as soon as I can. There's been a lot of new people finding the channel, so if you're new here, thank you for watching. And it's been an overwhelming amount of support, but it's also an overwhelming amount of comments, so I've been falling behind a little bit on trying to answer comments. So if you get a reply 3 days later, please don't be mad at me. I'm just trying to respond to everyone, and I also have a lot of stuff besides YouTube to do, so I'm really busy. But yes, if you have any comments or questions, please feel free to leave them down below. And that's going to conclude it for the F16v5 tutorial. For the next video, I'm hoping to start working on the behind the scenes of the Christmas light show. It's probably not going to be out before Christmas time because I've been super busy also trying to post videos on Bridgeport's brightest lights of the light show, so please bear with me if it takes a while to get that video out. But thank you everyone for watching. I hope you learned something new in this tutorial, and I'll see you in the next video.